In this stoichiometry problem, we will be doing an example of a limiting reagent. Limiting reagent is defined by the reactant in a chemical reaction that limits the amount of product that can be formed. Just like any other stoichiometry problem, it starts with a balanced equation. In this double replacement equation, barium chloride is added to iron hydroxide to yield barium hydroxide and iron chloride. You begin a reaction with 25 grams of barium chloride and 30 grams of iron hydroxide. We want to know which is the limiting reactant, how much of barium hydroxide we expect to produce from each reactant, and how much excess reagent is left over after the reaction is complete. So first we'll calculate how many grams of barium hydroxide will be made from 25 grams of barium chloride. We will ignore completely the amount of iron hydroxide involved as we're doing this calculation. At this point, we'll follow the basics of stoichiometry. To start, we need to know the molar mass of barium. Element 56 is 137.33. And 2 times the mass of chloride is 70.906. To get the molar ratio, we look at the coefficients in our balanced equation. From barium chloride to barium hydroxide, the ratio is 3:3. Now we need to use the molar mass of barium hydroxide to find our final conversion factor. The total molar mass is 171.3438 grams per mole of barium hydroxide. Now that we have our equation set up, we simply have to do our math and figure out how many grams of barium hydroxide we can expect to get from 25 grams of barium chloride. Now we'll do the same calculation but for the iron hydroxide. Follow the same conversion factors. Grams of FeOH to moles of FeOH, and using our balanced equation, to find our molar ratios. Then it's exactly the same ending. The reactant that produces the lesser amount of product, in this case barium chloride, is known as the limiting reagent. As for the question of how much of barium hydroxide can be formed, we can expect to produce 20.5708 grams. At the point that you've run out of barium chloride, there's no more iron hydroxide to participate in the reaction. So some iron hydroxide will be left. How much exactly of the iron hydroxide is left over? To calculate excess reagents, we start with the limiting reagent of 25 grams of barium chloride. Use the same calculations of atomic masses of each reactant and compare the ratios to each other. The ending unit should be grams of iron hydroxide. We are not finished. 8.5532 grams is the amount of iron hydroxide that reacted, not what is left over. To find the amount of excess reactant remaining, subtract the amount that reacted from the amount in the original sample.